Today we are going to learn about differentiating more complex variables. The National 5 Essential Skills are surds and indices. Differentiating more complex variables. As we stated in the previous video, we need to remove all fractions, surds and brackets before differentiating. We also have some special derivatives. If fx equals 10x, then this will differentiate to 10. If fx equals 6, then this will differentiate to 0. And if we have fx equal to x squared minus 3x plus 7, the derivative becomes 2x minus 3. Therefore, if there's a coefficient in front of x to the power of 1, this differentiates to leave just the coefficient k. And if we have a number and we differentiate, it differentiates to 0. The key steps: simplify all fractions and surds, bring the power down in front of x and subtract 1 from the power, differentiate each term individually, and if we have any number, that will differentiate to 0.
Example 1. Differentiate the following. So f of x is equal to 2x minus 1 multiplied by x plus 2. So the first thing we have to do here is expand our brackets. So if we expand the brackets and collect our like terms, we get f of x is equal to 2x squared plus 3x minus 2. From there, now we can differentiate each term. So looking at the first term there, the power of 2 will come down and multiply with our coefficient of 2 to get 4 at the front, x, and we'll subtract 1 from the power. 3x will differentiate to just 3, and negative 2 will differentiate to 0. So the derivative here is 4x plus 3. Looking at the second example, we've got y equals x squared multiplied by a bracket. So the first thing we need to do is expand this bracket. Now remember, when you are expanding a bracket, we need to multiply each term in the bracket with the x squared. And when we're multiplying letters, we add our powers. So the first term becomes x to the power of 7. X squared multiplied by x to the power of a quarter, and we will need to add those powers there, and that would be 2 plus a quarter, which is 2 1/4, which we would write as top heavy fraction 9 over 4. And then x squared multiplied by negative 1 over x cubed. The x squared will multiply with the 1 on top of the fraction. So that last term there we will need to simplify. And the last term will simplify. We're dividing letters, we subtract the power, so 2 take away 3 is negative 1. So once we get our function to this stage, it is ready to differentiate. So dy by dx is equal to, bring the 7 down and take 1 off the power, so the first term is 7x to the power of 6. Again, bring the 9 over 4 down to the front of the x, so negative 9 over 4x. Now to get the power here, we will need to do a little bit of fraction work, which we can do here at the side of our page. So we have to do 9 over 4 take away 1, or 9 over 4 take away 4 over 4, which is 5 over 4. And then the last term there, negative 1 multiplied by the negative x will give a positive, and the power negative 1 take away 1 is negative 2. We'll just tidy it up a little bit so that we don't have an answer with a negative power within it. And the final solution there is 7x to the power of 6 minus 9 over 4x to the 5 over 4 plus 1 over x squared. Example 2. Here we have to differentiate two examples with fractions. When we have expressions with fractions, the first thing we have to do is split it up from one fraction into 2. So if we have a little look at example A, we can rewrite this as 6x over x plus 5 over x. Then using our rules of indices, the first term we can cancel our x's to become 6, and the second term, if we bring the x up and give it a negative power, which would be 5x to the power of minus 1. From there, we can differentiate. So f dashed x equals, the 6 will go to 0, and the second term, negative 1 times 5 is negative 5, x, take 1 away from negative 1, and the power is negative 2. We should write our final answer with a positive power, which would be negative 5 over x squared. Looking at the second example here, we will again split it into two fractions, but at the same time, we should also change our root x to x to the power of a half. Now, we will need to remember our rules of indices. When we are dividing letters, we take away their powers. So at the side of your page, we should do our work with our fractions. So the first term, we have to do 3 halves take away 1 half, which is 2 halves, which equals 1. So the first x term will have a power of 1. And the second term, we've got 4 take away a half, which is equal to 3 and 1 half, which can write top heavy as 7 over 2. So the second power of x is 7 over 2. Now the next thing we need to consider is the number 2 in the bottom of each fraction. That is not a 2, but is actually 1 half. So our expression simplified is 1 half x to the power of 1 plus 1 half x to the power of 7 over 2. From there, differentiating, the first term will become 1 half, and the second term, if we bring the 7 over 2 down and multiply by 1 half, we get 7 over 4 x, and 7 over 2 take away 1 is 5 over 2. Please remember again to do work on fractions at the side of your page.
Now try these examples on your own. Please pause the video. The answers: A, the derivative is equal to negative 1 over 2 root x to the power of 5. B, the derivative is 5 over 2 root x cubed plus 5 over 6, sixth root of x. And C, dy by dx equals 3 over 5x squared minus 3 over 5. Please self-assess your progress. For extra practice, turn to page 95, exercise 6G, questions 1 to 3, and then questions 13 to 27. What have we learned today? We've been differentiating more complex variables. The key steps are simplifying any fractions and surds, also removing brackets. We bring the power down in front of x and subtract 1 from our power. We differentiate each term individually, and if we have any number, that will differentiate to 0.